friends, I'm Greeshma and you're watching my channel GTutorial. In today's class, we will be learning about basics of algebra. I have posted a video on algebra and its link is provided in the description box. Here I plan to put such a video because if you are referring the previous question papers, we can see that mostly questions are asked from the portion quadratic equation. How to solve the quadratic equation? If a root is given, find the other root. Find the sum of roots of a quadratic equation. If a variable k is present in a quadratic equation and it is unknown, we are given any of the roots, so we are asked to find the value of k. Such questions are asked. So understanding basis is very much important. If you like my video, please subscribe to my channel for getting more RRB related videos. Now let us get to our portion. First we can see what is algebra. It is a branch of mathematics where we use letters to represent unknown quantities. We are using letters to represent unknown quantities and these letters are called variables because they take variable values, changing values. So these letters are called variables. We can use any of the English alphabet as variables: X, Y, Z, A, B, C, P, Q, R. Any of the letters can be used as variables. And first let us see what is meant by expression. What is meant by algebraic expression? It is a combination of variables and operators. That is, it is a combination of these letters and operators. We are mainly dealing with four main operation in mathematics. That is addition, subtraction, multiplication and division. 4x plus 5. This is an example for an algebraic expression. Here we are using variable x and the two terms are separated by an operator plus. We can form an algebraic expression for the given example. Veena is 2 years older than Varsha. An algebraic expression for this is, if we are assuming the age of Varsha as x, then the age of Veena is 2 years older than Varsha. Then age of Veena is x plus 2, Varsha's age plus 2. Okay, so this is an expression for this statement. If you are seeing this quadratic equation 4x plus 5, here 4x and 5 are the terms of quadratic equation. That is, it is separated, these two are separated by an operator. So these are called terms of quadratic equation. There are two terms in this quadratic equation. Similarly here also, x and 2 are the terms, true terms of this quadratic equation. Next thing is the 4x. If you are considering 4x, then this 4 is called coefficient of x. And here 5 is called constant. Now we can see what is meant by an equation. Equation is a condition on a variable. If you are considering the previous example, and in that it is given that Veena is 12 years old and the second statement is Veena is 2 years older than Varsha. So the unknown is Varsha. Varsha's age we are taking it as x. So Veena is 2 years older than, so x plus 2 is equal to Veena's age is 12 years. So if you are equating it to some value, then that is called an equation. If you are equating the expression, algebraic expression to a constant, then it is called an equation. And here the condition is that the value of x should be a specific one in order to get the answer as 12. So if it is 10, the value is 12. If it is only 10, so the condition on x is that it should be 10 to get the value of this equation as 12. Now I think you are clear with the term expression and equation. It is a condition on a variable. And only if condition is satisfied, it is called an equation. Next is what we can see that what is monomial, binomial, trinomial and polynomial. An algebraic expression with only one term is called as monomial. 4x is an example of a monomial. Here there is only one term. Binomial is 4x plus 5. This is a binomial. Trinomial 4x plus 3y plus 5. This is a trinomial. There are three terms. And polynomial is an algebraic expression with one or more terms. So, monomial, binomial, trinomial, etc. are polynomial. The general term to denote these are known as polynomial. So, generally an algebraic expression is called a polynomial. Next, we can learn about polynomial in one variable. That is, we are dealing with an algebraic expression, x plus 5 or x square plus 2x plus 3. Here we are, in this algebraic expression, we are using only a single variable x. There is no other variables present in that algebraic equation. Such an polynomial is called polynomial in one variable. And the highest power of the variable in a polynomial is called the degree of the polynomial. In this example, the degree of the polynomial is x raised to 1. So, degree of polynomial is 1. Here the degree is the highest degree of x is 2. So, degree of the polynomial is 2. Here it is also, here is 2, here it is 5 because the highest degree is 5. And in this case, if you are given a constant, the degree of the polynomial is 0 because 5 can be expressed as 5 into x raised to 0. Anything raised to 0 is 1. So 5 into 1 is 5. So we can express 5 as 5x raised to 0. So the degree is 0. Such a polynomial is called a constant, which is called zero polynomial. Constant is called as zero polynomial. And a polynomial of degree 1 is called linear polynomial. 4x is a linear polynomial, x plus 5 is a linear polynomial, and expression with degree as 2 is called a quadratic polynomial. When degree is 2, it is called quadratic polynomial. When degree is 3, it is called cubic polynomial. So, when degree is 0, zero polynomial, 1 linear polynomial, 2 quadratic, and 3 cubic polynomial. Next, we can see what is meant by zero of a polynomial. If you are considering a polynomial x minus 1, then the zero of polynomial is called what value of x when substituted in this algebraic expression equates this expression to 0. So, if you are substituting x is equal to 1, then we will get p of 1 as 1 minus 1, which is equal to 0. So, 1 is called zero of this polynomial x minus 1, or 1 is called root of the polynomial equation x minus 1 is equal to 0. It is called zero of the polynomial x minus 1, or 1 is also called root of the polynomial equation x minus 1 is equal to 0. Another example, x square minus 3x plus 2. If you are substituting x is equal to 2, then we will get 2 square is 4 minus 3 into 2 is 6 plus 2, which is equal to 0. So, 2 is the root of, 2 is the zero of the polynomial x square minus 3x plus 2, or it is the root of equation x square minus 3x plus 2 is equal to 0. Okay, I think you are clear with what is meant by zero or root. Now let us learn about factorization of polynomials. In that, let us first learn what is meant by factor theorem. If p of x is a polynomial of degree n, which is greater than 1, and a is a real number, then x minus a is a factor of polynomial p of x if p of a is 0. That is, if you are given an expression, then and a is any polynomial, any real number, then if you are substituting that value of a for x, then if the polynomial equates to 0, then that real number a is not real number a, that x minus a is said to be a factor of that polynomial p of x. Or conversely, we can say p of a is 0 if x minus a is factor of p of x. We can see an example. Find the value of k if x minus 1 is a factor of this. We are given a polynomial 4x cube plus 3x square minus 4x plus k. And it is said that x minus 1 is the factor. If x minus 1 is a factor, then x is equal to 1. P of x equal to, x minus 1 is a factor. So, P of, here A is, this is equal to 0, x is equal to 1. So, here A is equal to 1. So, P of 1 should be equal to 0. Only then x minus 1 can be a factor of this polynomial. So, if you are substituting for 1 in this expression, it is given that x minus 1 is a factor. So, we can substitute. So, P of 1 is 0 and so we can substitute for x as 1. So, 4 into 1 plus 3 into 1 minus 4 into 1 plus k is equal to 0. From here we will get 4 plus 3 minus 4 plus k is equal to 0. So, k is equal to minus 3. Here asked to find the value of k. I think you are very clear. If p of x is a polynomial of degree n and a is any real number, then x minus a is said to be a factor only if that value of a, when substituted in the given equation, equates that polynomial to 0. So, if we are asked to find the value of k and we are given a factor of the polynomial, we can easily solve by using this thing. That is, p of a is equal to 0. Substituting the value of a in the equation, we will get the value of k. Now let us see a previous question from RRB. If x plus 2 is a factor of ax square minus 5x plus 6 is equal to 0, then a is equal to. Here we are given a polynomial. P of x is equal to ax square minus 5x plus 6 is equal to 0. And it is said that x plus 2 is a factor. If x plus 2 is a factor, then we can equate it to 0. So, value of x is equal to minus 2. So, p of minus 2 should be equal to 0 if x plus 2 is a factor. So, we can substitute p of minus 2 is a into minus 2 square minus 5 into minus 2 plus 6 is equal to 0. We are substituting for x as minus 2. So, 2 square is 4a minus 5 plus 10 plus 6 is equal to 0. So, 4a plus 16 is equal to 0, or 4a is equal to minus 16 by 4, which is equal to minus 4. Minus 16, and a is equal to minus 16 by 4, which is equal to minus 4. Now let us learn how to factorize a quadratic equation. That is, a polynomial having degree 2 is called a quadratic equation. And now let us learn how to factorize this and also how to find the zeros or roots of the quadratic equation. So, x square, we are given a question, x square minus 3x plus 2. We have to factorize this. For that, we are taking the middle term. Just draw a diamond shape. The middle term is the sum. And the extreme terms, the product of extreme terms is the product. So here, if a quadratic equation is of general form ax square plus bx plus c, then we are denoting the b, including the sign over here, and a into c over here. We have to take the sign for both these. So this is called sum and this is called product. Here the sum is minus 3 and the product is 1 into 2. And we have to factorize this product. Here 2. The factors of 2 are 1 into 2. Plus or minus 1, plus or minus 2. So plus 1, minus 1, plus 2 and minus 2. These are the factors of 2. So we have to find sum. We have to split this minus 3 into 2 terms, so that the sum is minus 3x and the product is 2. Sum is minus 3x minus 3 and product is 2. We have to split 2 into 2. So, in order to get the sum as minus 3, the sign should be, one of the signs should be minus, or in order to get this product as 2, the sign should be either both positive or both negative. But the sum should be negative. So, the possible choice is minus 1 into minus 2. Minus 1 into minus 2 is 2 and minus 1 plus minus 2 is minus 3. So the possible choice is minus 1 and minus 2. So we are splitting this equation as x square minus 1x minus 2x plus 2. Splitting 3s as minus 1x minus 2x. Now let us consider the first two terms and the last two terms. From the first two terms, x is common, so x minus 1 minus 2. We are taking minus 2 as common, so x minus into minus is plus. So we are putting a minus over here. Then we have taken 2 outside, so minus 1. From this term and this term, x minus 1 is common. So x minus 1 is taken outside. The remaining term is x minus 2. So here x minus 1 and x minus 2 are the factors of x square minus 3x plus 2. These are the factors. That is, if you are putting x equal to 1 in this equation turns to 0, or if you are putting 2 also, the equation turns to 0. So these are the factors of this particular quadratic equation. Now the next thing we have to find is, we have to find the 0 or root of the equation. If you are equating this, x minus 1 is equal to 0 and x minus 2 is equal to 0, then in the first case we will get x is equal to 1, and the second case we will get x is equal to 2. So x is equal to 1 and 2 are the roots or zeros of the equation x square minus 3x plus 2. Okay. Now let us learn something which is very important, and questions are asked from this section. It is very important to learn this. If you are given a quadratic equation as ax square plus bx plus c, then the sum of roots, we can find the roots. The sum of roots will be equal to minus b by a, that is minus the coefficient of x by the coefficient of x square, minus b by a. And the product of roots will be c, constant term divided by coefficient of x square, c by a. This is very important. Questions are asked from this. And so, in this example, we can cross-check this. Sum of root. We have obtained the root of this quadratic equation as 1 and 2. So, sum of the root is 1 plus 2, which is equal to 3. This is LHS. And RHS is, it is minus b by a. In this equation, it is minus of b is minus 3 by a is 1. So, 3. LHS and RHS is equal. So, this is correct. Next is product of roots. Product of roots. LHS is equal to product is 1 into 2, which is 2. RHS is c by a. That is, c is 2 by a is 1. So, 2. LHS equal to RHS. So, we have verified that sum of roots is b minus b by a and product of roots is c by a. So, what we have found, what roots we have found is correct. Okay. Sum of roots is minus b by a and product of roots is c by a. General expression is ax square plus bx. We have to consider the sign. If here it is minus 3, then b is minus 3. In this case, we have taken like that. Expression is ax square plus bx plus c minus b by a is sum of roots. So, if here it is minus, you have to take minus of minus 3. Don't make mistake. It is very important. Next question. This is the first question. Sum of squares of roots of equation is x square minus 5x plus 4 is equal to 0 is. This is one of the previous question. Here we are asked to find the sum of squares of roots of this equation. This is a quadratic equation, x square minus 5x plus 4 equal to 0. Let us take alpha and beta be the roots. And we have learned that sum of roots is equal to minus b by a. Here b is minus 5. So, minus of minus 5 by a is 1. So, it is 5. And we have learned that product of roots alpha into beta is c by a. Here c is 4 by a is 1. So, 4. We are asked to find square of sum of squares of roots. If the roots are alpha and beta, sum of squares is alpha square plus beta square. This is what we are asked to find. We know that the expansion of a plus b the whole square is a square plus b square plus 2ab. So, if you have, here we are asked to find this. So, alpha plus alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. So alpha plus beta is 5. 5 square minus 2 into alpha beta is 4. So 25 minus 2 4s are 25 minus 8 is 17. This is the answer of this question. Quadratic formula is another method of finding the root of quadratic equation. If the quadratic equation is ax square plus bx plus c is equal to 0, then by using quadratic formula we can find the value of root as x is equal to minus b plus or minus root of b square minus 4ac by 2a. This is b, this is a, and this is c. C is a constant, b is a coefficient of x, and a is a coefficient of x squared. And here the value that is within the root is called as discriminant. And discriminant d is equal to b square minus 4ac. Depending on the value of discriminant, there are 4 main cases. If d is greater than 0, that is b square minus 4ac is greater than 0, then the roots are distinct and real. Next case is if d is equal to 0, that is b square minus 4ac is equal to 0. The roots are distinct and equal. That is here, if this term is 0, the root is b by 2a minus b by 2a. So the two roots are equal and they are also distinct. Next is d less than 0. That is b square minus 4ac is negative, is less than 0 or negative value. Then within the root negative value comes. So the roots are imaginary. That is I minus b plus or minus I a value by 2a. It comes like that. Okay. Now we can do a problem based on this concept. This is a previous year RRB question. The value of k for which 3x square minus 5x plus 2k is equal to 0 has equal roots. Here we are asked to find the value of k for which this quadratic equation has equal roots. A quadratic equation has equal roots when discriminant is equal to 0. That is b square minus 4ac is equal to 0. Then this quadratic equation has equal roots. Here ax square plus bx plus c is equal to 0 is our general quadratic equation. Here the equation is 3x square minus 5x plus 2k is equal to 0. So a is 3, b is minus 5 and c is 2k. So let us substitute in this equation. B square minus 4ac is equal to 0. B is minus 5. Minus 5 square minus 4 into a is 3 into 2k is equal to 0. So minus 5 square is 25 minus 4 3s are 12, 12 2s are 24k is equal to 0. Or 25 is equal to 24k. So the value of k is 25 by 24. Now let us do a question to factorize a polynomial of degree 3. The question is x cube plus 8x square plus 17x plus 10. We are asked to factorize this polynomial of degree 3, cubical polynomial. So here we have seen how to factorize a quadratic equation. In this case, the sum is this. Sum is 10. Sorry, product is 10. And the sum is the coefficient of x squared. Sum is equal to 8. So, in the earlier case, we have found that we have to factorize, we have to find the factors of this product. Here, 10 is a product. We have to factorize the 10. Factors of 10 are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So the factors are plus 1 minus 1, plus 2 minus 2, plus 5 minus 5, plus 10 and minus 10. We have to get the product as 10 and sum as 8. So we have to choose from this 3 terms, 3 numbers which will lead to product as 10 and sum as. In quadratic equation we have chosen 2. In cubical polynomial we had to choose 3 numbers. So 1 into 2 into 5 is 10. Let us choose 1 into 2 into plus 1 into plus 2 into plus 5. 5 into 2 into 1 is 10. And 1 plus 2 plus 5 is 8. So the answer is x plus 1 into x plus 2 into x plus 5. These are the factors of this equation. And if you are asked to find the zeros, then equate each of this to 0. That is, x is equal to minus 1, x is equal to minus 2 and x is equal to minus 5 are the zeros of this polynomial. Now let us do another question. This is the next question. X cube plus 3x square minus 13x minus 50. So we have here the product is minus 15 and the sum is 3. So we have to factorize this term 15. Factors of 15 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5 and plus or minus 50. We have to choose 3 numbers so that the sum is 3 and product is minus 50. So the numbers are 1, minus 3 and 5. 5 into minus 3 into 1 is minus 15. So 5 minus 5 plus 1, 6 minus 3 is 3. Okay. So the numbers are 1, minus 3 and 5. So the factors are x plus 1, x minus 3 and x plus 5. These are the factors of this polynomial. And the zeros are equating each of this to 0. So x is equal to minus 1, x is equal to 3 and x is equal to minus 5 are the zeros of this polynomial. Now we have covered almost every topic from the portion algebra. If you are having any doubt, you can comment below. Thank you.